the next phase. So that is why I was saying.
Okay. No problem. We will start studying hydrogen. Okay. So if you talk about the hydrogen, right?
Yes.
So hydrogen is the many expect it is very important. Okay. Hydrogen. First,
Yes.
why it is kept in the syllabus? There are some reason are there why it is kept. First one is the H2 is the best fuel. H2 is best fuel. Okay, the reason is this one. It is the best fuel. Why it is best fuel? Because when it is burns in the air, suppose it is burning, it's the side product is what H2O. Side product is H2O and the heat. So this H2O is that is what pollution free. No pollution. It is not going to cause the any pollution. That is why nowadays what the everybody is trying to switch toward the in the terms of energy, they are turning switching towards what? That is the hydrogen economy or hydrogen fuel, right? Second one, there is the compound called that is D2O. D2O. This is called heavy water, HEAVY. This is the heavy water. This compound is called heavy water. And this compound is extremely important. Why this compound is extremely important? Used in, where we are used in nuclear reactor. Nuclear reactor. We are going to use nuclear reactor. Okay, nuclear reactor as a moderator. We are going to use. So in the nuclear reactor, it is used as a moderator. That is why this is second one is also important. One more point are also there. The third one important was there, H2O2. This is H2H2. H2O2 that is called a hydrogen peroxide, that you know. Hydrogen peroxide. Peroxide.
Yes.
This hydrogen peroxide is strong. This is the oxidizing agent. Simply I am saying this is the oxidizing agent. Okay. This is the oxidizing agent. It oxidizes many of the substances to the oxidize like that. What is oxidized? Fe2 plus to Fe3 plus. This is the ferrous to ferric. This one is there. Like that many are there. The reaction like that is sulfite is there. SO3 2 minus 2 sulfate ion. SO4 2 minus. Like that H2S is there. This is also going to convert into the sulfur. So it act as a what it is acting as the oxidizing agent. So this is the somewhat introduction part of the hydrogen, that it is the extremely important for this one. One more thing there, actually hydrogen, it gives some other compound also. So we are talking about this one, hydrogen. Okay. So first things, this hydrogen is it is lightest. It is the lightest, Lightest, lightest gas. Lightest gas in the form of H2. Okay. And also, what is that is also lightest element. Lightest element. Lightest element of all known element. Whatever the known elements are there, in which that is hydrogen is the lightest element. Okay, so this is what the one thing are there. Okay, secondly, if you talk about the hydrogen, it is the most important component of the biosystem. Most important. If any of the compound you named it, any of the compound, whatever the compound you think of the organic compound, that will be the compulsory, there will be the hydrogen. Okay, suppose whatever we are eating, C6H12O6, the major component the hydrogen. If you are drinking the water, major component is the water. If you are the petroleum product you are using, major component is the hydrogen. So hydrogen
proteins are also having hydrogen in their amino acid.
amino acid like that, NH2. It is there C. Here is the, suppose it is the R. This side is H is there. This is the COOH. So what you are find, this R means what? It can be any alkyl group. Either it will be the CH3 or it will be CH2, CH3. So here what you are going to find, that is the hydrogen is going to comprise the almost most of the organic compound containing the hydrogen. Means the organic compound, when you are talking about organic compound, so two elements are common. What is there? The carbon and hydrogen. Not only common, this is the compulsory element. This is the compulsory element. Which compulsory element are there? Carbon and hydrogen. Rest of the element will be in the different proportion. Now, the next point what we are going, that is the isotopes. Isotopes of hydrogen. Isotopes of hydrogen. That you must be knowing, isotopes of hydrogen. Okay. The isotopes of hydrogen are also extremely important because they are able to give the different compound and also the compounds which are very important. What are the isotopes? They are having the 3 isotopes. Isotopes. What are the 3 isotopes? If I will name them.
The protium, deuterium, tritium.
This is the protium, protium. One second. This is the protium. This is the 1H1. Second one is deuterium. That is the 1D2. Or that is 1H2 also, remember. And the last one is tritium. Okay, tritium. Now, the question is 1T3 or 1H3. That is the same symbol. The question is, in which isotopes of the hydrogen there is no neutron? Can you please tell me?
Sir, protium.
Protium, there is no neutron. Which isotopes is the what we are talking about, the radioactive? Any idea about that? Which isotope? Tritium. Tritium is the radioactive. Deuterium is not the radioactive. It acts as a nuclear reactor. I know it just we use the to stop any reactions, right? It is, but it is not the radioactive. Tritium is the radioactive. What is the lifetime of the tritium? Any idea about that? What is the lifetime of the tritium? It is 11 or the 12 hours, 11 or 12 hours. It is the very less lifetime is there. I'm just searching out the notes because you earlier did not inform now. So I am not also well prepared to this topic. I need to see that one. You give me 1 minute, so let me take out the notes. 1 minute. Redox reaction chemical study, inorganic group studies. Just 1 minute. Let me find out the notes. It's not there. Okay. So this is there. So you got to know this is the tritium is this element is what is the radioactive, and it is its lifetime is the very small lifetime, right? Now we are going to study the compound of the hydrogen. So the first, many things I am not telling you. How the preparation are also there. The study of hydrogen gas, okay, hydrogen gas. Okay. So now you give me 2 minutes. Okay.
Yes.
Okay. So if you talk about we are just switching to the hydrogen. Do you know the one more question? Just let me ask the question. Position of the hydrogen in periodic table. What is the position of hydrogen? Position of hydrogen in periodic table. Can you tell me? Position of hydrogen in periodic table.
Sir, first group, first period.
First region.
Region.
Hmm.
The reason I don't know. Because it is the lowest number. Lowest number.
Okay. See, that is the why long form periodic table phase, because it does not explain the exact position of the hydrogen. There is the failure of the long form periodic table, modern periodic table, because it could not explain the position of hydrogen. Why it could not explain? This is the only reason. That is why long form periodic table failed. The reason is what? It is having the property. What the properties are there? Property with group 1. Properties similar to group 1. That is similar to group 1. And second one is there, properties similar to group 17. There are also properties similar to group 17. Similar to group 17. Although it is kept in the group number 1, but it is having the properties, two group properties are there. Hydrogen. Now if you talk about the hydrogen, helium, lithium, okay, sodium, hydrogen, beryllium, lithium, sodium. So there is the one valence electron are there. Here is 1. Here is the 2, 1. Okay. Here is the 11 is there. So that is going to be 2, 8, 1. So if you see the basic things, that is what you are going to find. That is 1 valence electron is there. So they are going to, that is what going to kept in the group number 1. Another things, it is forming the monovalent ion. No, unipositive charge ion. It will form also 1 plus. It is also form 1 plus. Here is also form the Na plus. So this is one thing is there that we can kept with the metal. But what are there? The problem is there, that is all other than the hydrogen, all are metal. How can you keep the non-metal? Because what the long form periodic table said, that is the element in the same group are similar in chemical and physical properties. Similarities in the properties. But here if you see, whatever that is hydrogen are there, lithium are there, sodium, potassium, rubidium, cesium, and francium. These all the elements are metal. This is metal. But here is this is the gas. That is non-metal.
So that is the only non-metal in the first period.
So how can you say that they are the period of the group properties of the group elements are similar? That is the problem, one thing. Second, if you go in the group 17, how can you see the reaction, a specific reaction you see? How the chlorine see? Hydrogen is having the 1 electron. It can gain 1 electron. It can form the H minus. Now it is having the configuration 1, 2. That is 2 electron, right? A stable duplet. A stable duplet. Yes or no? Yes or no? H minus means 2 electron. Now you go the fluorine. Fluorine also taking 1 electron, it forming the F minus. Means F minus means stable. So it is the configuration was what? 2, 7. So it become 2, 8. So gaining 1 electron, then becoming the stable octet. So while gaining the 1 electron, they are becoming the stable, like the chlorine, 2, 8, 7. This is there. And it is gaining the 1 electron. So it is forming the Cl minus. So here is this is also Cl minus means 2, 8, 8. So that is stable octet. Now, if I will talk about that, how can you kept with the other group if it is the taking 1 electron just like hydrogen and making the stable? And secondly, that is that they all are non-metal. They are non-metal. Hydrogen also. Hydrogen, if you talk about hydrogen, fluorine, chlorine, bromine, iodine, they are non-metal. So it should be properly kept with what? The halogen, right? Now, you see the similarity otherwise. H plus Cl. H plus Cl. It is giving the compound similar. Na plus Cl. It is again going to compound, give the similar. K plus Cl. So it is going to give the compound similar. It means this is showing, this is for the group 1. This is for group 1. So one property it is also there, that it should be kept in the group 1. Second, see, Na2 do not exist. K2 do not exist. Li2 do not exist. But here, if you talk about halogen X2, in case of halogen, H2, Cl2, F2, Br2. So where can you explain? Where should you keep? So some properties it is similar to what is there, similar to halogen. Similar to halogen. So it should be kept. It should be kept which group? it should be kept which group? Group 17. Group 17, because many properties are representing with the group 17, taking one electron, becoming stable, forming the compound like H2Cl2 Br2, and some properties it is giving one electron, so one positive charge, so it can be kept in the group 1. So where actually we should keep this element? That is the becoming the reason of failure of the modern periodic table. So at now, it is the confirmed position of hydrogen is not decided, because it is having the property similar to group 1 and similar to group number 17. This is what the problem in this case. Okay. Are you be able to understand any point?
Yes.
Okay. Now, on the basis of atomic number and electronic configuration, it is kept in the group number 1. Why? Because it is having the electronic configuration 1, and we are filling that increasing order of the atomic number, so that it is taking the first position. That is okay. But properties wise, it is not the actually, it belongs to group number 1. Properties wise, it can be group 17 also. Now, isotopes we have done. Now, the next method we are going to study the method study of hydrogen. Achha, you tell me, hydrogen is what type of gas? Study of hydrogen. What type of gas is there? Hydrogen. Please tell me.
Sir,
What is the
get your question.
what is the gas? This is the flammable, non-flammable. What is this?
Gas is flammable, but it has no odor, no color.
This is the flammable. No, flammable. What sound? What sound? What sound?
Sir, pop sound is
Pop sound. Pop sound with matchstick. This is the.
Sir,
This is.
sir, what is the word you have written before hydrogen? So this one.
What?
Sir, what is this word, sir, you have written? This one.
Hydrogen. Oh, no. Study of hydrogen. So we are going to preparation. Preparation is also quite important for this one. Industrial preparation are important. Lab preparation are important. There are many methods are there for preparing the hydrogen. So the first method which we are going to study, that is the industrial method that is required. Okay. For us,
Yes,
we need so let me find out the what is the industrial method for this one. Yeah. If you see the industrial methods, there is the carbon reacting with the steam. It is there. One more reaction is there. Have you studied this one? CH4 and O2. CH4 and O2. This reaction is there. CH4 and O2. Anywhere did you study? CH4 and O2.
sir, I think the class
Okay. One more things.
in class
CH4 and O2, if you are talking about, so it will give the firstly, it is not going to give this one. That one method is there, H2O. And this is the steam. This is steam. So if you are treating with this one, so it is going to what that is give the CO plus hydrogen gas. Okay, this is hydrogen gas. How many hydrogen molecules? 3 hydrogen. This together, they are known as synthesis gas. Synthesis gas. Okay, synthesis gas. Syngas. And one more is there, CO plus N2. This is called producer gas. Producer gas. Okay. So this is not coming now. Here, this is the synthesis gas, also known as syngas. SYN. This is the syngas. Now, this is the also method for the industrial preparation of hydrogen. Industrial preparation of hydrogen. In the industry, this is the method what we use to prepare what we prepare, that is hydrogen gas. How much temperature it is required? 1270 degrees Celsius, and we have to take the catalyst. Where it is given? This is the 11th volume second. This is the second volume, and chapter is the hydrocarbon. This is hydrocarbon. This is there, and also it is given in the NCERT, this chapter also. So how you are preparing? You are passing the steam. to the methane. So if you are passing steam to the methane, it is going to give what? The carbon monoxide and the hydrogen gas. Hydrogen gas, this is the industrial method. Huge amount of this is used. Now, the next method, other method you already know very well. What you can do, that is the suppose sodium metal is there, active metal. Active metal. If you are taking the active metal and putting in the water, H2O. So what it is going to happen, Sanoy? That is, take the two molecules that you study in the 10th standard. So metal will dissolve in the water. It gives the sodium hydroxide, and release the hydrogen gas. This is the simple. Next one is the metal. Metal reacting with the metal plus acid. Metal plus acid. What it is going to give? The salt plus. This is again going to give the hydrogen gas. So metal, what is any of the metal you can take? What is, suppose I am taking Mg and then I am taking 2HCl. 2HCl. So what it is going to give? This is the MgCl2 and this is again going to give the hydrogen gas. Okay. Let us see the laboratory preparation. If you talk about laboratory preparation, this is what we use in the laboratory. Generally, you must be knowing in the laboratory, this reaction we perform. Like that zinc reaction is there. Zinc plus H2SO4 dilute, always we have to take the dilute acid, otherwise it will give start burning. Okay, highly flammable reaction. So it is going to give ZnSO4 plus hydrogen gas. This method, when you are talking about this method, this is what is called the laboratory method. Laboratory method. Okay, this method we use in the laboratory. Can it be okay?
Yes.
Now, one reaction is there. Water gas shift reaction. Water gas shift reaction. Sometimes this is asked, water gas shift reaction. How the water gas shift reaction is going to be? See, if you are having the coke, COKE, and you are passing the steam to it, STEAM. So it is going to give the CO plus hydrogen gas. CO plus hydrogen gas. This is okay. This is again going to be the syngas, SYN, syngas. Now, this molecule, what you are taking, CO plus H2, you add the water molecule again. So if you are adding the water molecule, CO2 plus it will give the CH2O. Okay. CO2 plus not H2O, sorry. CO2 plus H2. This reaction is called water gas shift reaction. Water gas shift reaction means to produce more amount of the hydrogen gas, we use the steam. Again, we use the steam or water to make the more production of hydrogen gas. Okay, it means to shift the reaction in forward direction to produce more reaction. What we do, we add the water molecule in the system. We add the water molecule in gas, like the Le-Chatelier principle you study. The similar reaction are there. If you are adding this one hydrogen, so it is converting into the carbon dioxide and hydrogen. You see the here is per mole, 1 mole is there. It will be the 2 mole. So this reaction is called water gas shift reaction. CO2 will be removed and hydrogen will be used. This is what the water gas shift reaction. So this one reaction you have to understand. Can you be able to?
Yes.
Next one. We are having the one is the commercial preparation. Commercial, COMMERCIAL. Commercial preparation. This is the also given in NCERT that you need to know. Commercially, by the electrolysis of water. By electrolysis of water. Electrolysis of water. If you are doing the electrolysis of water, it can be prepared. Means now we are having the H2O. Okay. So you explain how can you do the electrolysis of water? What the product you are going to get? Can you explain this one?
There are 2 hydrogen and 1 oxygen.
2 hydrogen and 1 oxygen. What the reaction? At what electrode it is going to obtain? First one you are electricity you are passing. So first step it is what is giving, that is 4H plus. 4H plus. And 2O2 minus. Okay. So which gas is going to liberate at anode and which gas is liberating at cathode? At anode. If you are talking about at anode, what reaction takes place? Oxidation. Oxidation means loss or gain of electron.
The loss of electron.
Loss of electron. Thank you. So this oxygen is there now. So 2O2 minus, right? So what we have to do, that is the 4 electron is going to be out, 4 electron out, and it is going to form O2. Where it is going to form, that is anode. Is it the oxidation? Here charge is 0, here negative. So this becomes the oxidation. Okay, this is the oxidation. Next one, see, at cathode. At cathode. So what you are taking? Suppose you are taking 4H plus and you are adding the 4 electron minus. So it is going to be 2H2. Okay, gas. Where it is forming, that is, it is forming at the cathode. How can you say this is the plus 1 charge is there? This is 0. So this is what is happening. That is the reduction. This is the reduction. Can you understand this one? No.
I understood.
Okay. Then we are going to properties of dihydrogen.
Sir, can you please keep the previous slide for some time, sir? I was noting that down.
Okay, okay. Thing is, you. Okay, no problem.
So this is anode loss of electron.
Done.
So just 1 minute. The last line.
Okay, no problem.
So done.
Okay, thank you. One more point we are going to add, that is ortho and para hydrogen. Okay, ortho and para hydrogen. Have you heard about this one? Ortho and para hydrogen. Okay.
Sir, I've heard only the names ortho and para, sir. They were in the chapter 4 chemical bonding, sir. The ortho nitrophenol and para.
No, this is not. Ortho hydrogen and para hydrogen. This is the different things are there. See in the here is the this is the two hydrogen atom. Two hydrogen atom we are talking about in H2 molecule. There are two hydrogen are there. Here is the center is there. Okay. Now the point is there. If the spin is the parallel, this one. If the spin of what, that is proton. Proton in the center. This is what the spin of proton. Proton. If the proton spin is what they are saying, parallel. Parallel. So if it is parallel, that is called orthohydrogen. Orthohydrogen. I will share the notes to you. Orthohydrogen. Okay. And if the spin of the proton in the nucleus, what is there? Anti-parallel. If it is the anti-parallel, suppose it is going to clockwise, so other is going to be the anti-clockwise. Okay. So that is anti-parallel proton. Anti-parallel proton. If it is the anti-parallel proton, so what is there? That is this is the orthohydrogen. Orthohydrogen. No, wait. Ortho upper one, this is the para-hydrogen. This will come sometime. It is asked in the NEET exam, para-hydrogen. Only the problem is there when hydrogen molecule, I am reading the line now. When the spin of the two proton are in the same direction, when the spin of the two proton are in the same direction in a molecule known as orthohydrogen, while when the spin of proton are in the opposite direction, hydrogen formed is known as the para-hydrogen. So here in the proton, what is there? In the hydrogen atom, there is the proton is there, yes or no? So in the proton, if the spin of the proton is what is called, that is clockwise there, that is the same direction, that is what is ortho. If it is the opposite direction, that is what is para-hydrogen. That you little bit, if you can keep in mind, that will be good for you. Okay. Now the second point. Second point, chemical properties of hydrogen. Chemical properties of hydrogen. Chemical properties of hydrogen. Chemical properties of hydrogen. Okay. So the first one you see, the first one, hydrogen, it react with the many of the species. We are going to write the simple way. This one. There are the so many reaction are there. The most important is the with the nitrogen. With the nitrogen. So what is there? H2 plus, no, 3H2 plus N2. The reversible reaction are there. It will give the 2NH3 plus it give the heat to heat. This is what is this is what is called. What is the Haber process? You are saying Haber process, yes, na?
Yes, sir.
Haber process for production of the ammonia. This is the most important compound for the production of ammonia. How much heat liberated if you talk about delta H is equal to minus 92 joule, 2 kilojoule per mole. This much of heat is liberated. Okay. Now, that is what the first reaction. Now, the another reaction which we can go with oxygen. So it is also give the oxygen. It will give the too much of amount of the heat. So you are taking 2H2 plus O2. So it is going to give 2H2O. And delta H here it is there minus 285.9 kilojoule per mole. Scientists are in the search of this one. How to break the bonding in the water molecule. Okay. So even the, see, what is happening here? This is the exothermic process. Whenever the hydrogen and oxygen combining, it is forming the water molecule, and that is also going to be the exothermic process. And next one is if you are talking about halogen, if I am treating with the halogen. So any of the halogen you can read that is H2 plus X2. So it is going to give that is HX2HX. But the what is the reactivity of the halogen is what is highly reactive F2. Then it is going to react with the Cl2. Then it is going to react with the Br2, and it is going to react with the I2. The reactivity of halogen is this one. Always keep in mind fluorine is the most reactive, then chlorine, then bromine, and then iodine. It is reactive with the hydrogen, the order of reactivity. Okay. Nitrogen we have done. It can react with the sulfur also and form the important compound. Sulfur, you know very well, that is the H2 plus sulfur. If you are treating, that is what you got H2S, hydrogen sulfide. This is also the important compound, hydrogen sulfide. This is the reducing agent. That is why it is the important compound. Next one is reaction with metal. So metal, that is also important. Suppose what we can say that is if you are treating with the sodium and hydrogen, it is forming that is NaH. Okay. This is plus and minus. This is the sodium hydride. Sodium hydride. This sodium hydride is that is what is again it is going to be reducing agent. This is the reducing agent. That is why hydrides are also important. Any other reaction are there? That is okay. Okay. I am erasing this one. Now, that is the another, the compound. Now we are reaching to the compound of hydrogen. Compound. Hydrogen we study compounds of hydrogen. What the compound you need to study, that is the first thing you need to study, the hydrides. Okay, hydrides. With hydrides you need to study, that is metal hydrides you need to study. First point is we need to study the metal hydride and its type. It is there in your syllabus, metal hydrides and its type. Second thing which we have to study, that is the compound. Second one is there H2O, and third one is there H2O2. This many compounds we are supposed to study. Now, you explain to me what is the metal hydride. Any line you can explain?
The reaction, the compound of a particular metal with hydrogen atom.
Okay. How the so see IDE term is being used. This is means that is the hydrogen will be used. Hydrogen is having what? Negative charge and metal will be the positive charge. Right? How it is going to form? Yes, yes. So metal hydrides are actually, they are the ionic compound. This is the ionic compound. Metal hydrides are, they are the going to be the ionic compound. Okay. Now, three types of hydrides are we are supposed to study. Three types of hydride. Three types of hydride.
Sir, actually, between 9, 10, sir, actually, I'm having a maths class now. Sir, can I join that one?
Okay, then tomorrow, what time you are be able to join? What time? Because today you did late, na. That is why. Tomorrow we'll fully study the hydrogen only. Okay, we'll finish the hydrogen. You join 8 to 10. Is it possible?
Sir, 8 a.m.
8 to 10 or 8:30 to 10:30?
Sir, we can do 8:30 to 10:30.
Okay, so you kindly be available 8:30. Okay, you. Once the very sharp you available, because we are not studying anything today. Also, we could not study anything. Just only introduction. Tomorrow tomorrow we will study full hydrogen. Okay. Okay. Bye.
Okay, sir.
Hmm.
Okay.